All right. Good afternoon, everyone. My name is Jeremie Capron. I'm Director of Research with ROBO Global. I'd like to invite our speakers back to the stage. So I hope this gave you a sense of the robotics, automation, AI revolution that's really moving forward, and particularly of its breadth and how it's touching so many sectors of the economy today. We've heard it from the professors. I think we should also listen to the market, because the market is telling us that something important is happening. We've seen the ROBO index in the past 3 years return an average of 25% per year. So the stock market is telling us, what you're talking about is real, and it's turning into businesses. So I'd like to ask you, each one of you, to start the conversation, what do you think has been a major breakthrough in the past 2 or 3 years? I mean, you've all talked about many different things, but if you had to pinpoint one, perhaps an enabling technology or a new application of robotics, what would it be? And let's start with you, Raf.
Okay, so maybe I'm going to answer a slightly different question. Of course, you hear about deep learning, I think, has made tremendous impact in image recognition. But I'm going to answer something maybe a little bit more forward-looking, and I think it's what excites me as something that could be a major breakthrough, and I think is around the corner. I think it's battery technology. I think that if we made a microprocessor that was twice as fast or used 2 times less power, okay. If you made a battery that had double the energy density or was twice as, half the size, it has such a huge multiplier in the applications, especially for things like robotics. Obviously, for things that fly, that is a huge multiplier. And I think that there's enough people working on the problem and are starting companies and are transitioning to the market that I think we're going to see real impact in that area in the next couple of years.
So there are tremendous advances in each of the 3 critical areas for robotics: brains, bodies, and interaction with users. Since you asked about one, I will point to the convergence between materials and machines, the convergence between computation and machines, with machines becoming softer, like in the case of soft robot grippers and soft robot arms, and materials becoming more capable of communication and computation and sensing. So this convergence between materials and machines will lead to a whole new set of robots with a whole new different set of capabilities.
Henrik?
Well, so I very much agree with Daniela, and so I think where we will see sort of the biggest sort of progress short term will actually be in getting much better hands. So new technology where we can integrate in better sensing into this will allow us to get much better. So today, most of the hands we have on robot systems are very primitive. So being able to do fruit picking, handling all that is a tremendous market where we can actually do this, and we can do it much better than we can do it today. So we're going to see manipulators are going to be a big deal, and then I would argue the revolution we've seen sort of the last few years is in collaborative robotics. The fact that we've taken down the fences around the robots, put them next to people, collaborating with people, that's sort of been the big progress over the last sort of 3 to 5 years. And then I would claim short-term moving forward, it's the new materials, new sensing, allowing us to do much more flexible hands. That's where the revolution is going to be.
Now, we hear a lot about AI. In the last couple of years, I think AI has become a real buzzword. And although we take great care at researching what AI is and how it's being deployed in various businesses today, I'm curious, what do you all think about this AI renaissance? And I would ask you, Daniela, as Director of the Computer Science and Artificial Intelligence Lab at MIT, the CCL has been around for a very long time, but it seems AI is only coming to the fore today. So tell us what's real, what's not, and how it's changing the game in robotics.
So AI, I should say, started in some sense at MIT with Marvin Minsky, who gathered his friends in 1956, went to the woods of New Hampshire, and then came up with the idea of the science and engineering of intelligence. And we have seen ups and downs in the field, but in the recent past, the advances in data, in computation, and in algorithms have created new capabilities that that will revolutionize many applications. With new AI technologies, we will be able to transport people and goods faster. We will keep you safe on the roads. We will be able to ensure customized medical treatments and better engineer, monitor disease. With AI, we're enabling instantaneous conversations between people, no matter what language they speak. With AI, we will really provide tools for people to offload their routine tasks and really focus on critical thinking. This is all coming, but I think it's really important to understand that, in fact, AI is not a magic bullet, and it's not going to solve all of our problems, just like it's not going to take down the world. It's also important to keep in mind the relationship between three fields that are all progressing in parallel, but they are quite different. So one is artificial intelligence, which gives machines the ability to reason, to see like humans, to speak like humans. The other one is robotics, which puts computation in motion. And the third one is machine learning. Machine learning cuts across AI and robotics and enables us to learn from data and make predictions from data. And all fields that have data can benefit. And if I might just say one quick example, it's also important to keep in mind that machines make mistakes in how they process the world. And so I want to illustrate this with an example from medicine, where recently, in a study done at Harvard, machines and doctors were asked to look at scans of lymph node cells and classify them as cancer or not cancer. The machines made 7.5% error, as compared to the humans' 3.5% error. But when the machines and the people worked together, the error dropped down to 0.5%. So it's a huge improvement in the accuracy of the diagnosis, because machines can do some things better than people and vice versa. Machines can see in those images things that we cannot see with the human eye, but the machine will not be able to make a reliable prediction. However, the machine could say to the doctor, hey, look in this area and see whether there is something there. So the thing to keep in mind is machines and people working together, because the techniques we have in AI and machine learning are still limited. They still make mistakes, and for that reason, they are not provable. They cannot be applied in guaranteed ways for applications that require precision and control.
And Raf, is AI a game changer in your field?
I think AI is a piece of it, right? If you look at, even in ROBO, we have this classification. It's the computation part, but there's still the sensing part, there's still the actuation part, there's still the architecture. How do you put a system together in the right way? And all of those are equally important. So it's a piece of it. And then there's the other flip side, which is more of the entrepreneurial side, is how do you make sense of these new capabilities? How do you exploit them? What are the new business models that these things enable? I think that's also a key part. I think it's an important component. I think that there's a lot of speculation that is going on. I wouldn't call it a bubble, but there's a lot of speculation, and some of the stuff will pan out, some of it won't.
So as we cover the robotics, automation, AI industry on a global basis, something we've noticed is that the fund flows in China have been very, very impressive. In the last 5 years, China has gone from being a drop in the bucket in terms of VC fundings to becoming perhaps on par with the US this year in terms of funding tech startups. What do you see coming out of China in robotics and AI? Do you think China is set to take over the world like it has already in terms of the number of factory robots being installed every year.
So I don't know if I'm ready to just say China is taking over, but I think we are seeing massive amounts of investments in China comparatively. So we're seeing at least compared to the US right now, a 5-time bigger investment. I would at the same time say, if we go back and look at it, there is also a lot of investments that are not necessarily very smart investments. So I think in terms of smart investments, we're probably on par with them in terms of the US. We're also seeing major investments in Europe through the Horizon 2020 program and the new program. You are seeing these massive investments. But it's true, if you look at the gradient in China is very impressive. We are seeing people getting in, both in terms of sort of smart manipulation, in terms of new types of doing sensing. And I think one of the advantages is they're working with big companies like Tencent, Alibaba, and Huawei on really figuring out how do we embed these technologies also into new types of processors, new types of communication. So they're trying to build an infrastructure that will allow them longer term to have an ecosystem around this that could be very powerful.
So China has a national program in AI, and they have goals. By 2020, they want to be caught up. By 2030, they want to be the leaders. And China has good track record when they set national priorities. In fact, a few years ago, they wanted to be #1 in high-speed trains. 5 years later, they had 60% of the market in high-speed trains. And then recently, they wanted to embrace entrepreneurship. Within a year, they had 8,000 incubators and 89,000 graduated startups from those incubators. It is extraordinary. These days, when I go to China, I see that the money is absolutely infinite if you want to do anything with AI and robotics, but the secret is you have to do it in China. So money does not leave China. But if you want to work there, the money is infinite. And the young people have so much hunger and ambition and, frankly, creativity in many ways.
Raf? Do you want to add to that?
Not much to add. I think that I think it's a good thing that folks are investing and that people collaborate and create new devices. There is a lot of Chinese money that leaves China. Actually, there's a lot of investment and recent articles being written about how much China is investing in Silicon Valley, for example. So, but as Henrik said, just because you're throwing money at it doesn't mean that you're going to go faster. You have to be smart about it.
At the same time, I think it's sort of interesting they're also they're thinking long-term about it. So they're making massive investments in STEM education. And just to give you a data point, there are more people below the age of 10 in China than there are people in the US. So if you really redirect the STEM workforce at this, you can have very massive, we haven't seen, so as Daniela said, we don't really have sort of a national AI strategy in the US, and we don't necessarily have an educational system that promotes STEM and those things. So I think it's worth looking at what can you learn from, what can you do with the laws of big numbers?
So just in the same vein, to amplify what you said, Henrik, there is mandatory computer science education in China and in many other countries. Not so in our country. Now, what I would promote is computational thinking and computational making, because the physical aspect of computation is important. But I tell you, I have increasingly more and more people who come to my lab and want to take our robot compiler projects and they want to map them onto high school projects. And so there is a lot of thinking in bringing the robotic and the physical aspect into the education system. And the other thing I want to say is that so in China, there is way more data than we have in our country. And when we look at AI algorithms are only as good as the data that is used to train them. So more data means better trained product. Better trained product means more users. More users means more revenue, which means more researchers and engineers, and the cycle continues. And so that's something to be kept in mind. I guess the final thing I will say is that in China also, The attitude towards rules and policies is much more relaxed than in our country. So it's much easier. So China is much more pro-experimentation, and they don't figure out all the implications and the reliability and the ethical implications of deploying the technology. So there is much more agility in putting products on the road.
Just making a last comment about education, I think that the way we're talking about it, I think it's even much simpler. I live in Europe where people think about education differently than here. Here I hear stories of teachers that have to buy their own supplies because the school can't afford it so they can give it to their kids. Maybe that's not your kids because you can send them to a private school or you live in a good neighborhood, but there's a lot of folks that don't have this opportunity, and that's the resource that you want to tap into, because creativity doesn't care about race, it doesn't care about anything else. It's there. You got to tap into that because that's missing a huge opportunity.
So let's continue on this topic of education, because what I find in our research, meeting with the leaders of the ROBO Index member companies, is that a recurring theme is always how they struggle to secure the talent that they need to continue to grow their business. And that's valid for factory automation, that's valid in healthcare, robotics, and pretty much across the spectrum. And for you as professors and teaching our young students, I'd like to hear if you could give us some color here, a sense of the numbers. Are you seeing sufficient growth in terms of the number of students that we can train around these technologies? And are you seeing perhaps some alternative ways of training people for these new technologies?
I'll say two things. One, the growth is definitely something visible. Our department in Switzerland, I'm in a mechanical and process engineering department, which kind of sits at the systems level. We've seen a double in the last 5 years, the number of students that are enrolled. Where I'm at, it's all merit-based, so people don't have to spend $50,000 a year to go to school. They spend $1,000 a year. It's all based on your capabilities. So we're seeing huge growth. I think the importance of project-based education should not be underestimated, not just teaching folks, the theoretical part, but actually have them do real stuff and work in teams to make that happen, across teams that cross boundaries. It's a huge, valuable learning skill. I think those are very important aspects of it. I think students, young people are really excited about the area, especially robotics, because it's so easy to see what it can do. So I think that the demand is there, the supply is there. I think we just have to make sure that we're efficient and forward-looking into what the best way to meet those two things are.
So I would say that to me there's no doubt we're seeing significant growth. At the same time, I think it's very important that we sort of represent the high end of the education. I think it's very important. We need to build the entire pipeline. Not everybody needs a bachelor or a PhD or a master's to be able to, this is sort of the wrong. So how do we educate the future workforce in a way where we fill the full pipeline? And at the same time, I think the universities are going to get disrupted within the next 15 years. Totally disrupted. So when I got my degree, people sort of gave me a diploma and said, okay, go conquer the world. That's not going to work anymore. We need to get to an educational mentality where everybody gets 10 minutes of education every day for the rest of your life. Because we move so fast in terms of technology that it's very unrealistic that we don't get a continuous update all the time. And I would claim that the current universities worldwide are thinking about sort of the church model. The priest is standing up there and sort of preaching to the crowd. This is not the future of education. It's problem-based education. It's doing it in your workplace. So we're going to see, and AI and other technologies will help us make this accessible to the crowd. But we have to start not thinking just in a diploma, but in how do you sign up for whatever that educational model is that will educate you for the rest of your life as our technology continues to sort of see exponential growth.
So to amplify what Raf and Henrik said, we have to rethink what is literacy in the 21st century. And I would really like to see the undergraduate computer science and AI program shifted to schools. This would actually ensure that in 10 years' time we have a graduating class of high schoolers equipped with a lot of IT skills that they don't have today. But moving forward and linking to what Raf said, I will tell you that at MIT the interest in our field and in our courses and in our students is tremendous. And we don't have enough students to send off to companies. The salaries in robotics and in AI are 10 to 20x and even higher than the salaries at universities. And so we really have a big difference. Yeah, so we have a really big a big gap, and so if we think about the future professors who have this choice, it's kind of a deep and important question to keep in mind. The other one is that if we want to hire more, if we want to train more students so that we have more to hire, then we also need the R&D investments that would allow us to train the students according to the model, the financial model we have in our country. So I think we need to rethink how universities, financial companies, and industry work together to provide a good platform for training the next generation to ensure that we continue to have people interested in scientific discovery and training, and people interested in entrepreneurship, and people interested in working with companies. At MIT, we often talk about do not eat the seed corn and do not hire the farmers.
So one final question maybe for you, Raf. So we talked earlier today about the various technological revolutions that we've gone through, and I'd like you to talk about how you view robotics and AI as a technology transition or revolution, and compare it to the internet.
Right. So, I mean, that's a very broad question. Maybe I'll just say one part of it. You know, if we go back to 2000 and we look at, you know, the internet, it was very different in 2000 than it was in 2002, right? And, you know, everyone was excited about it, and then everybody said, oh, this thing is a bubble. Folks like Warren Buffett, you know, had the foresight in 2000 to not invest in the internet, and did not have the foresight to invest back in it in 2002. So there's going to be ups and downs, right? I think that there's a lot of excitement about the space. I think in the short term, you could see some downsides. I think in the medium to long term, it's just so obvious that this capability of being able to take information from the real world and influence it, this feedback effect that has never happened before in history, it just has so many capabilities. The demographics are there to leverage these innovations. As folks get older, you know, we need more of these sorts of systems to help us in our daily lives. As new models of entrepreneurship are happening, new models of making revenue service-based, more folks doing services. I think this is just a huge growth area, but there's definitely going to be some ups and downs.
All right, well, with that, I want to thank you very much, Raf, Daniela, Henrik. We're very privileged to be working with you at ROBO Global, and thank you for your presentations today.
Thank you.